Use the weights of cans of generic soda as sample 1 and use the weights of cans of the diet version of that soda as sample 2. Assume that the two samples are independent, simple random samples selected from normally distributed populations. Do not assume that the population standard deviations are equal. Construct a 90% confidence interval estimate of the difference between the mean weight of the cans of generic soda and the mean weight of cans of the diet version of that soda. Does there appear to be a difference between the mean weights? If we click this icon, then we will see the data set listed. We are told to use the generic sodas as sample 1 and then the diet soda as sample 2. Now, we can open this in StatCrunch by clicking on this little icon here, this little rectangle, and then say Open in StatCrunch. We're supposed to construct a 90% confidence interval. So we will click Stat, Tstats, to sample, with data. Sample 1, we were told, should be the generic soda. Sample 2, we were told, should be the diet soda. We were also told not to assume that the population standard deviations are equal. So we will unclick the Pool Variances box. We are supposed to construct a 90% confidence interval, so we'll make sure that we check the confidence interval box and set the confidence level to 90. Now let's click Compute, and we're going to be given some upper and lower limits. Our lower limit is 0.0065 if we round to 4 decimal places as called for in the problem, and our upper limit will be 0.0250. Does there appear to be a difference between the mean weights? One thing that we need to notice about this interval is that it is completely in the positive range. 0 is not included in this interval. So we are 90% confident that there is a positive difference between these population means. So we would conclude that the mean for population 1 is greater than the mean for population 2.